Another math problem. All right, let's see. This mathematical problem was uh, given by one of my students. Now, I think the main problem is not the problem itself. It's not this math problem itself. I think we are trying to figure out methods how we can actually solve this more effectively or maybe in a more efficient way, right? Now, let me see. Assuming that we have no idea how to sketch this graph, because most of the time this is not the typical straight line or quadratic graph that we recognize. But you do need to understand the concept of domain here, though. Now, take for instance, for first question, state the range of the function f. Now, for the function f, domain given is here. This is the domain. All right, so I better write that down just as a reminder. The domain is more than 2. Now, using a bit of intuition and number logic, for any real numbers x that is greater than 2, we notice that the denominator would increase as the x increases. So therefore, the value of f would be reducing or would be decreasing as x increases more than 2. All right. So knowing this is very, very important. And then other than that, this is the first thing that we need to know before we can answer this question A here. The second thing we need to know is something like, is there any minimum then? Since for any x that is greater than 2, the denominator is increasing. Therefore, the value of x will be reducing or decreasing. But how far would the fx decreases in this case? Would it decreases forever? Will it decrease until negative infinity? Or will it decrease to a certain fixed number? This is where we need to at least understand the idea of asymptote. So we are talking about the horizontal asymptote here. So let me write that down first. So you have to recognize, at least to a certain extent, there is an existence of horizontal asymptote. Now, as the x approaching, we are looking at a positive real number here, approaching infinity. What will happen to the fx? So in this case, it's quite obvious. The fx would be approaching 2. This can be considered as the lowest value, but it's approaching though, which means it will not be crossing that y equal to 2 there. Now, knowing this, and then knowing that the domain is greater than 2, and then knowing that the fx would be reducing. Function fx is decreasing for x is greater than 2. In mathematical literature, if you are interested, there is a term for this. This type of function is known as the monotonic function. A functions where increases or decreases in one directions, right? So since it only decreases in one directions, then at least we know the scope where the range of fx would be. So in this case, we would know that the range. But anyway, there's one little thing that we need to know there. All right, now fx is decreasing for every x is more than 2, and then you'll be approaching 2, considered as the lowest value that the functions might be approaching. So therefore, we can conclude this range now. You might be wondering how we can conclude um, if we only knew about the lowest point. Do I know the highest point? Do I know the highest point here? That's the thing. So the other thing you might want to test out would be as x is approaching. I would say as x is approaching a 2 there, that fx would be approaching infinity. So this is the third informations that we need. You don't really need to show all this. These are just informations that I lay out here for your own understanding. Of course, in the exam, if this one only give you 1 mark, you don't really need to show this. But the knowledge of the property of this rational function is very important. Knowing this, we can conclude that a, the function fx would have a range. The range of fx would be, the fx would be lying in between. All right, now you can write formally or informally, up to you in this case, but in this case we know that this must be greater than a 2 for the range. Since the lowest is 2, the highest is infinity. Therefore, the first range will be here. Okay, so I hope everyone understand on this. On to question B now. Now, using the understanding of questions A, we know that for B, fx is, and sorry, okay, hold on. Fx is a decreasing, right? Fx is a decreasing function. Now, when I say it is decreasing functions, we are looking at the decreasing functions for this domain, for x lying between 2 and 4. Right? And then we know that as the x is approaching 2, fx is approaching infinity. And then for 4, since x equal to 4 is not asymptote, so we can actually plug this value into gx. Okay, did I use the gx correct? Oh, sorry, I'm referring to the wrong function. Okay, hold on. This is supposed to be gx, even though both of the function is the same, but their restrictions and constraint is different. Gx is approaching infinity. Right. Now for x equal to 4, we can figure out what is the y value in this case. So that would be 6. So from here we can conclude that the x is we can conclude that gx is greater than 6 and then less than infinity. So our first impressions would be gx must be greater than 6 and then must be less than infinity. Or to put it simply, we can say that the range for gx is basically greater than 6. Right, now that's for B. Right? And then the finding for B is important for question C now. Right. Now for question C, let's look at question C here. fgx. Okay, let's try to work out with fgx. So fgx. So fgx is basically a composite functions of fgx in this case. Now, one thing we need to understand here would be the gx, the range for gx in this case would become the domain. Don't forget, this range for gx will become the domain for fx. Right now, this is the most important concept that we need to um, get through. Right? So the range for gx in this case would become the domain for the functions fx. So let's check out or let's recall the range for gx from sections B. So the range for gx is greater than 6, which mean the domain for fx now is x is greater than 6. So x must be greater than 6 for the functions fx in this composite functions process. Right. Now, knowing that, we can work out the range for fgx now. Right. So all we need to do is to just focus on the domain for x that is greater than 6 there. Since x equal to 6 is not the asymptote, so we can find out the y value for fx in this case. So when x is equal to 6, let's figure out what is fx in this case. So if I did the calculations correctly, that would be a 4. Right? That would be a 4. And then fx is a decreasing function. Fx is a decreasing functions, and then therefore we can conclude that at this point fx must be greater than 2, because the minimum value for this fx is 2 because it's decreasing. And then this one is less than, right? We can see that because fx is decreasing, we can treat 4 as a maximum value at this point. So this is less than a 4, right? And then there you have it. That's the range for this composite function. Okay, I hope that you are clear on this. The understanding of the domain and function is super important in this case, right? Okay, let's move on to the last section, sections 2 here. Okay, now explain why the function gf cannot be formed. Right, cannot be formed. Let's give it a try and see why we can't form this function. So gfx is a composite function. It basically is the same. It's just my bad habit of writing in this notation. It's easier for me to visually comprehend the composite function in this case, right? So we are looking at gfx, and then there are things we need to check before we move on with the finding the composite function. Of course, finding the composite functions algebraically shouldn't be a problem. It's merely a case of substitutions. But before we perform that, we have to figure out the range. As in question C, we can state that the range for fx. Now this range for fx would become the domain for gx in this case, right? Now from A we know that the domain in this case, the range for fx. The range for fx, we know that fx is basically greater than 2 from the first questions there. And then therefore the domain for gx, domain for gx is x is greater than a 2, right? X is greater than a 2, right? So, is it possible for us to have a domain of gx greater than 2? Yes, is possible. Hold on, just let me check through one more time in this case. So the domain will be greater than 2. Now, since x is between 2 and 4, okay, it's greater than 2. Right, hold on. Just let me get this point where we know that the domain for gx is actually greater than 2. X is greater than 2. Yeah, right. And then knowing that the range for fx is greater than 2, therefore we can conclude that the domain for gx in this case is greater than 2. And then now we need to use this understanding to check why we can't form these functions based on the constraint. Right, now we can say that we can form the function gf. Right? Gf is available. I would say gf can be constructed for the restricted domain, which is x is greater than 2, less than 4. Yeah, that is true. But because the domain is x is greater than 2 in this case, it might actually exceed 4. And then we know that gx does not exist anything more than 4. Right? Now, because gx is not it's not valid for x greater than or equal to 4, therefore we can conclude that gfx cannot cannot exist, I would say, or cannot be formed, if you like, for x that is greater than 2 is a open domain in this case, which is not restricted to this domain here. Right, now that is the conclusions for questions number 2. I hope that is clear to all of you. Right. Now that is the algebraic approach, and then with the help of a bit of intuition, I would say. Right. Now, from my point of view, the best way to attempt this question, of course, is to be able to construct or sketch out the graph as detailed as possible. So from the graph, we can answer A, B, C, and then number 2 quite directly in this case. Right? Now let's take a look at method 2 then by using a graph. Okay, let me erase off this. All right, now using a graph method. All right, using a graphing method. Okay, using a graphing method. Since both of the function is the same, it's just that the constraint is different or domain is different. I can just sketch one graph to represent both. It's just that I need to narrow down the domain in this case. So my focus is to sketch this graph. Now, sketching the graph, I would say roughly it will look something like this. So it's also a good practice to revisit how to sketch a graph properly in this case. Right? Now we always start with looking at if there's any intersections with the x-axis and the y-axis in this case. So we found that the graph does pass through the y-axis at I would say -2 here. If you substitute x equal to 0 here, so it would be -2 around here. And then the other thing we need to be sure of is to check if there's any vertical asymptote. It's quite obvious that there's a vertical asymptote here, which appear to be a 2. So I'm going to use a different color just to denote the asymptote. Okay, this is the asymptote, x equal to 2. And then I might also want to check if there's any horizontal asymptote. Now you can let x approach infinity. So as x approach infinity, we found that these fractional expressions would approach 0. Therefore, the whole function would be approaching a 2 here. And then we can say that y equal to 2 is the horizontal asymptote in this case. So I will mark this down as 2. This is y equal to 2. Now that will be another asymptote. And then finally, all I need to do is just sketch out based on what I knew about this. Okay, now I might want to find out where it intersects the x-axis also in this case. So let me see. We have the let me see. It's a 4. Okay, I will let y equal to 0 in this case. So that will be okay. There will be a -4. -4. There will be a -2. Let me see whether I got a -2 or not. So -2. Yep. So that is actually a -2 here. Okay. So it passed through an x-axis at x equal to -2. Yep. So I'm going to sketch the graph. The graph would look something like this. Let's see. Right, it's actually approaching the horizontal asymptote and then the vertical asymptote in such a manner. And then I can actually check out this quadrant here. You can try and error with any values that is greater than 2, and then you would eventually found that the graph will look something like this. Alright. And then from here is quite obvious. Just by using the graph, we can make our conclusions for number 1 quite easily. So for number 1a, state the range of the functions for because this function only exists for these sections here. So we can see that it only exists for this window or this domain here. Let me label that. This is the particular domain. So therefore, it's quite obvious that the range must be greater than 2. So the range for fx is greater than 2. Right. Now we are done. Okay. Now for b, state the range of the function gx. Now function fx and gx are pretty much the same. The only difference is the gx only appear between 2 and 4. So I will make a remark on this. Let's assume that somewhere here you have a 4, and then if I plug in, I found that f4 is pretty much a 6 here. So that is not drawn to scale. So please make sure that it's not drawn to scale from my point of view. That's the reason why it does not look very accurate in this case. Just a rough sketch. So we have a 6 there. So this is the point or intersection. Alright, now I shouldn't be using I should be using a hollow circle just to remind myself that it's not including that particular coordinate. Right. So it started off from here. And then sort of end at just before 4. Now from here, you would notice that the range for gx must be greater than a 6 here. Gx must be greater than a 6. It's quite obvious in this case, right? And then for C, we have the range for fg. Now the range for fg, we have looked at it just now, but by using graphical method is more intuition in this case, and then it's easier to relate. So I'll just complete this C and number 2. Right? It's pretty much the same as the explanations before. So for FG, we are looking at the range. So don't forget the range for GX would become the domain domain for fx in this case. And then because the range for gx is greater than 6, right? So therefore the domain for fx indirectly is greater than 6. So the domain for fx is greater than 6. So we are looking at somewhere here. So let's assume that this is 6. Anything greater than 6. Okay, I might want to mark this down. So anything greater than a 6. So anything greater than a 6. What are we typically looking at? So you might want to find out at this point where it would be intersecting. So you can substitute the 6 back into the fx functions. So we'll find that this is pretty much a 4. So we found that now the highest point, you can say the highest point is actually 4, and then it will be decreasing as we know, it will be decreasing, and then approaching y equal to 2. Therefore the range for fgx is, so in this case it would be more than 2, less than 4. So you can actually write down fgx more than a 2, less than a 4. Now there will be a range. And then number 2, I think you can refer back to the previous sections, the reason why GF cannot be formed in this case. Right? I hope that will be clear to everyone, and then I hope that is useful to your understandings of function in this case. Right? Thank you very much.